Hey guys, how's it going? So 5 o'clock Tuesday night, let's do some calculus. Although, like I said, this first part is a lot about vectors and we won't actually start doing calculus until a little bit later. Um, so since this is our first quote unquote regular class, I just want to give you a kind of a layout of how it's going to go. We'll get the hang of it together in this live online format. So, today you did the video lessons for 11.1 and 11.2, introduction to vectors and rectangular coordinates. Some days I'll do all my talking at the beginning and then let you work in groups the rest of the time. Some days, like today, we're going to do 11.1. I'm going to break you into groups, and then we'll come back and we'll talk about 11.2, and then hopefully we have some time at the end to do a little bit more work. The reason for that, a lot of days I'll do all my talking at the beginning just because of the time it takes to break into groups and come back and break into groups. And we just don't have that much. And I want to maximize our time in here so you guys get the most out of it. So with that said, I've got the PowerPoint up here for 11.1. Again, as a reminder, all the PowerPoints are available and more. Hopefully you saw, along with the link for the course, I put the links to the worksheets and the links to the PowerPoint. So I'll do that every Tuesday and Thursday so that they're easy for you guys to get, because I want you to have access to the PowerPoints. All right, because sometimes I might go too fast through them for you guys to take notes. So if you have access to them, then you don't have to write down what's on the PowerPoint. You can just put it in the part that you want. And I want you to have the worksheets because, once we break into groups, you're going to work some problems from the worksheets. So today, since this is our first day working in groups, I'm just going to randomly do the groups. In the future, we might move into more set groups, especially if you have people that you work with in other classes that you want to work with. I'm going to talk a little bit about that at the end, and I'll also send out an email. But with that being said, I want to dive into 11.1 because, we need to get started. I'm barring crazy stuff, I'm always going to be very punctual. I'll be starting at 5 because, again, it's just so easy to run out of time with some of these live online classes. I want to make sure that we get through as much as we can. All right. A lot of times when I'm going over stuff on the screen, I'll keep my webcam off. I feel like it can be more distracting than helpful. Like I said, I'm turning it on in the beginning because we're just kind of chatting. So I'm going to go through and when I'm talking, feel free to ask questions. You can ask questions. I do have chat open. Sometimes I do miss it in chat because I'm looking at the screen and I have chat off to the side. Or if you want to turn on your whiteboard, excuse me. If you want to turn on your microphone and ask a question, that's fine too. You can see here I got a whiteboard on the left-hand side in case I need to write anything. I use whiteboard.fi. And that's because I can give you a link to it, which disappeared. Where's my link? Okay. So here's a link to the whiteboard that I'll be using. So that way, when you guys are in breakout rooms, if I do have any notes on the whiteboard, you guys will still have access to them. All right. It's not a bad little tool. Okay, let's go ahead and get started. We'll talk more about the groups when you guys are in groups. Today will be a good day for, when you're in groups, if you have questions about how to submit group work to let me know. All right. All right, with that, let's start talking about vectors. So 11.1, we're getting a basic introduction to vectors. All right. So let's just talk about what a vector is. A lot of you guys have probably seen vectors in a physics course or maybe a Calc 2 course. So they're not brand new. So this introductory stuff may seem repetitive, but it's going to be good. Vectors are great for organizing information. And when we do the calculus with it, it's going to be really nice as well. So the nice thing about a vector is it's what we call, it measures what we call a vector valued quantity. All right, it's got a magnitude and a direction. So we call that basic vector a displacement vector. Its tail is at one point and its tip is at the second point. So you start at the tip and end at, excuse me, you start at the tail and end at the tip. The magnitude of the vector is the distance between the points and is represented by the length of the arrow, and the direction is the direction of the arrow. Now, we contrast this with a scalar quantity, all right? And, you know, it's good to have the difference between the two. Most of the stuff you guys have done in calculus has dealt with scalar quantities so far. A very good example is velocity versus speed. Velocity is a vector valued quantity because it has magnitude and direction. Speed is the magnitude of the velocity, therefore it is just a scalar value. Okay, so the difference would be we're going 20 miles per hour in a northeast direction, that would be vector valued, versus we're going 20 miles per hour, that would be scalar. So we're not going to spend a ton of time on this. You guys have gone through the videos, but I do want to go through some basic things. You know, if you're, you know, let's talk about displacement. If you walked 3 miles north and 4 miles east, you have walked a total of 7 miles. That's your total distance that you've traveled. That's different than your displacement. Your displacement is measured from your starting position. So if you started here, went 3 miles north, 4 miles east, your displacement would be 5 miles at 60 degrees east of north. All right. There's several different ways we can denote that direction. I just happen to do east of north. And so when we're doing some of the problems from the worksheet today, don't forget to give specifically where your direction is being measured from. 60 degrees, well, 60 degrees from what? 60 degrees from a standard positive x-axis, 60 degrees from north, 60 degrees from south. So we want to be specific when we label our direction. Now, it turns out it doesn't matter if I go 3 miles north first and then 4 miles east, or 4 miles east and then 3 miles north. We actually get the same displacement because what we're doing is we're adding up the two vectors. So the order does not matter when we're adding vectors, just like when we're adding two numbers. Now here, let's talk about the case where we'd have subtraction of two vectors. So now we have two different people. One goes 3 miles north, the other goes 4 miles east. Right? Now we have two possible displacement vectors, one from here to here and one from here to here. So depending on which one we're looking for, we get actually a different vector. So that would be the vector from the person going east to the person going north. The opposite vector would actually have exactly the same magnitude. It would just have 180 degrees the opposite direction. So it is not the same vector. We could call them parallel vectors, but they are not the same vector. They just happen to have the same magnitude. Now this would be the difference, or the difference between two vectors. And just like with subtraction in numbers, the order matters. 5 minus 2 is 3. 2 minus 5 is -3. They have the same magnitude. They're both 3 units from 0, but in different directions. The same thing happens with vectors. It's one of the really nice things of vectors. Once you get used to them, once you're used to vectors, they're very, very easy to work with. All right. So that's what we're going to be looking at today and next week. Today we're just talking about the basics of vectors. Next week we'll talk about multiplying vectors. Again, I really just want to highlight some of the important things about vectors. I'm going to talk a little bit about the vector components. So a vector is considered the same regardless of its position in the plane. What that means is this vector here that's, I don't know, maybe two horizontal and 3 vertical units from the origin is actually the same vector as this vector starting at the origin. Those two vectors are the same vector because it would be made up of the same components. So a vector doesn't care where you're starting or ending in the plane. That part's on us. What it does do is it gives the displacement between the displacement between 2 points, the magnitude and direction between 2 points. Now, this is going to be something I'm going to harp on a lot when we deal with vectors, is thinking of them in terms of components. Because if we can break a vector down into components, it makes it much easier to deal with. When you guys go to do problems on the worksheet, you might want to break your vector into components. So our vector V has 2 components. It has a horizontal component and a vertical component. The reason we do this is because this allows us to write a vector in terms of its horizontal and vertical components. We'll call them, for instance, V1 and V2. Notice what we have here. If I took V2 and moved it over here, I have a right triangle. So what you're going to notice as we do a lot of stuff with these vectors, we end up using a lot of right angle trig, because that's where this all comes from. So you will see us using sines and cosines as we go forward. It's going to be very cool. One of the things I like about this class is we use a lot of the stuff that you've learned in previous classes. Obviously Calc 1 and Calc 2, but also trig. All right, some notation, okay? We have 2 notations for vectors. So first let's start off with our 2D vector. So we have our 2D vector. And there's 2 different notations, and I have a preference, but I don't force either of them. I'm particular to this first notation. I like the brackets. It's just what I always used when I took my classes. That's my horizontal component. That's my vertical component. All right. But you'll also see it written this way, as multiples of I and J. So I just want to talk a little bit about what those are. So anytime you see that little hat, that's what's telling us it's a vector. Please pardon my handwriting on these. I'm only so-so at writing on these tablets, so it won't always be the best. Guys, both of these notations are fine. They work exactly the same. The one thing I want you to be careful of, and I see it a lot, is you don't want to conflate the 2 notations. Like I don't want to put a plus in here, and I don't want to put brackets over here. So you decide what notation works best for you and run with it. All right, user's choice. But what this tells me is that V is made up of 2 components. This is its horizontal, and this is its vertical. Over here is the same thing. And what I and J are, they're unit vectors. I is a unit vector in the positive horizontal direction. J is a unit vector in the positive vertical direction. So if we had axes, I would be in this direction, J would be in this direction. All right. Because we are going to be moving into 3 space, actually, we're going to do some 3-dimensional stuff today that I think will be I hope you guys find pretty cool. I think it's pretty fun. We can do vectors in 3 space. All we do is add on the 3rd component. All right, we got the K here, which represents that 3rd Z-axis. So this would be like our x-axis, y-axis, z-axis. All right. We'll talk a little bit more about the axes in the second half of class, but they expand to 3 space. And one of the things about vectors is these things are n-dimensional. Now in here, most of the things we're going to do will be 2-dimensional or 3-dimensional. But, and I'll be sure to tell you, a lot of the stuff we do does expand into n-dimensional space. The reason we're going to deal with mostly 2 and 3D is because then we can create a visual representation of what's going on. Anything higher than 3D, we're unable to sketch it. All right. But these are the components, and this is taking a vector and breaking it into either 2 or 3 components, depending on if we have a 2D or 3D vector. And guys, if you have questions, you don't have to wait. Please feel free to ask, or if even if it's just my handwriting's messy and you can't read it, let me know. Because with this being a live online class, I don't get the visual cues that I would get in a normal classroom. So it can be hard for me to tell if you're following. So, if nobody asks questions, I'm just assuming that everybody's doing okay, and we'll keep moving. All right. Because I do want to try and make sure we answer as many questions as we can. That's what this time is for. All right. Here's something that's awesome about vectors. They're super easy to add or subtract. You basically just add or subtract the like components. All right. There's nothing crazy going on there. If we have the vector 2, 1, and we want to add the vector 7, -4, I just do the corresponding components. 2 plus 7 is 9. 1 plus a -4 is -3. There's my resulting vector. So adding and subtracting vectors is very easy. This guy here, we're going to see this Greek letter show up a lot. This is lambda, L-A-M-B-D-A. This is a Greek letter for lowercase l. It gets used a lot in math, and it's being used here to represent a scalar. So basically that means if I have some scalar times my vector, I can distribute it just like I would over a set of parentheses. This would be the vector 6, 3. That's all that's saying. The last one, magnitude of a vector. Notice what this looks like. Remember that, we said before, if we have some vector v, here's v1, here's v2, we got a right triangle. Well, check that out. If we have a right triangle, we know from the Pythagorean theorem, we have this relationship, square root that, and that gives you the magnitude of v. The reason I'm pointing this out is I don't want you to think of these as a bunch of formulas you have to memorize. Adding and subtracting vectors is very straightforward. Scalars is very straightforward. The magnitude is simply the Pythagorean theorem that you have been doing for years. All right. And this part says if you have a scalar times your vector, when you're taking the magnitude, you can just take the absolute value of your scalar. Because we're squaring and taking the square root, that'll turn any scalar from negative to positive, hence the absolute value, and then just take the magnitude of v. So if I were trying to find the magnitude of this vector, well, it's the absolute value of 3 times the magnitude of this vector. All right, that's all these notes are saying. And as a reminder, guys, I do not expect you to memorize a whole bunch of formulas for this class because we're going to see a lot. Remember, for the exams, you're going to have the note cards to put down formulas. So by all means, do not, when you're doing homework, don't worry about memorizing formulas, worry about applying them. Okay, 2 more things I want to talk about with vectors, and then we're going to go do some problems. Excuse me. All right, a vector between 2 points. If we have 2 points, so we have some point down here at 1, -2, I'm not going to worry about the axes, and we have some point up here. 3, 5. And we want to start here and go to 3, 5. So we would be going that direction. That means our guy's pointing this way. Because again, remember the direction matters, whether we're going up and to the right or down and to the left. If we wanted to represent this guy as a vector, let's call it V, we have to find its two components. Well, all we have to do is think about, well, how far did we go horizontally? Well, we ended at 3, we started at 1, so 3 minus 1. And then how far did we go vertically? We ended at 5, we started at -2, so 5 minus -2. And so the vector between those two is 2, 7. So we can generalize this method for both 2D and 3D. And I do want to point out, notice it was my ending point, or in other words, where the head of my arrow was, or the tail, was the tip, excuse me, minus the tail. So where you end minus where you start. If I did it the other way, you know, if I did this, the points here minus these points, I would have gotten -2, -7, which is almost the same vector, except it points in the opposite direction. 180 degrees opposite direction. Guys, this expands into 3D. We are going to be finding points very soon between 2 and 3, vectors pretty soon between 2 and 3 points. So we do need to be aware of that. Now, if our vector's tail is at the origin, then it makes it very easy because whatever our point is our vector because we're starting at 0, 0. And we'll do that sometimes when we're doing theorems just to simplify things. All right, one last thing I want to talk about before I cut you loose. Unit vectors. Unit vectors are a very important part of the stuff we're going to be doing today. They're not overly complex. They're a vector whose magnitude is 1. All right, the reason we like unit vectors is they preserve the direction but take away the magnitude. So once we start doing some vector multiplication next week, we'll have a little bit more reason for why we care about unit vectors. All we do is normalize a vector. Well, what does that mean? We take that by multiplying the vector by the reciprocal of its magnitude. Let's take a look at that. So if I wanted to find a unit vector for 2, 7, so I want a vector in the direction of 2, 7 that has a magnitude of 1. First thing I do, let's see, we called this guy V. First thing I do is I find the magnitude of V. Well, that's our Pythagorean theorem, square root of 2 squared plus 7 squared. So we got square root of 53. So a unit vector that points in the same direction is basically 1 over square root of 53, so 1 over the magnitude, times the vector 2, 7. This part here guarantees me that it's the same direction. This guarantees me that the magnitude is 1. All right? Now, here's something that's really cool about this. If I wanted a vector that had a magnitude of 10 that pointed in the same direction as this vector, all I got to do is multiply my unit vector by 10. And I'm guaranteed that that will have a magnitude of 10. All right, so that's one of the advantages of unit vectors. We can keep the direction and give any magnitude we want. Okay, that was what I wanted. Those were the highlights that I wanted to hit. So now we're going to be turning over to some group work. But before we do, any questions? in case you don't have it already, I'm going to put the link to the worksheet in chat. There we go. All right, so like I said, today we're going to do random groups. I'll talk a little bit more about groups at the end, but I want to get you guys doing some work in here. And depending on what group you're in, you're only going to do a couple of problems, okay? Everybody's going to do number 1, and group 1 is going to do 3, 2 is going to do 4. I'll push these whiteboards out to you guys if you want to use, if you're using whiteboard.fi, again, so give you the link here. All right, so once you're in groups, we did a little practice run on groups last time. So this is our first time actually working problems in groups. Let me kind of let you know the expectations. The expectation is for your group to work on these 2 problems. If you finish these 2 problems early in your group, go on to another problem. You know, there's an answer key on the second page of the worksheet. Let me bring the worksheet over. The answer key is right here, so you're going to be able to check your answers. We're going to skip number 2 on this worksheet just for time's sake. Feel free to work on another problem in your group, but those are the problems that your group is responsible for, and you're going to post in the forum. Only one person in your group has to post. Just make sure you include the names of the people you're working with, or more than one, or you can each post your own. When you work on the whiteboard, if you work on the collaborative whiteboard in Zoom, there's an option to save your work. So you can save it, and that's what you can upload. If you work on whiteboard.fi, same thing. You can just save your work to a PDF and post that. And if you write on a separate piece of paper on your desk, just take a picture of it, put the names of your group on it, and upload that. Okay. If you have questions about that, you know, ask me later. Just because of time's sake, I want to get you guys working. So we're going to break into 5 groups so I can get you guys going. Okay, you should have an invitation into the rooms. And again, I'll put a link to the whiteboard in there as well, so that you can, in case you forget which problem your group's supposed to be working on.
Hello.
Yes.
Hi. I didn't get an invitation.
You should see one because it says you're being invited to breakout room 3.
Oh, there we go. Okay, never mind. Sorry.
All right, perfect. Are you able to get into that breakout room, Ramses? Perfect. All right, guys, welcome back. As you can see, things always take a little longer than planned. I was hoping to have you back a little sooner, so we probably won't spend as much time on 11.2, but that's okay. I'm still going to hit the highlights. But as a reminder, don't forget to post the work you did on the two problems up on the forum later. Anytime tonight, guys. There's no real deadline for that. Once I see your post, that's when you get the participation points. All right. Save questions for that until after class. I'll hang around after 6:30, but I want to make sure for those people who have to leave at 6:30, we had a chance to talk about 11.2. There's a couple things I want to show you. We probably won't get to the worksheet for 11.2. But I'm still going to try and recommend that you guys do it. And if you want to post your solutions to the worksheet for 11.2, I'm more than happy to give you participation points for it. We just won't have time in class. All right. So rectangular coordinates in 3 dimensions. All right. So number one, you'll notice how about I share my screen, huh? Sorry, guys.
Quick question.
Yeah.
So I mean, for 11.2, the worksheets tells you to go to a website. How would we post that for participation points?
I'll show you. Let me share the screen here. Okay, can you guys see my screen?
Yeah, I can see it.
All right, so this is the website. The web address has changed from what was on the worksheet. I'm sending this to you now. Guys, we're going to use this pretty regularly in here. It's a 3D plotter. It's one thing to draw graphs in 2D. It's very difficult to draw them in 3D. So we will be using this for our 3D plots. I'll make sure I update the links in the course because I didn't realize the site had moved. That's pretty recent. Okay, so this 3D plotter. So my goal for this second part of class is to get you guys at least a little bit familiar with this 3D plotter because it's the one that I recommend. It's free. If you guys find another one that you like better, you are more than welcome to use it. By all means, if you like using things like Maple or even MATLAB, for those of you guys who are familiar with it, you can use that. But this will be the one that I'll use. There's videos. These are going to be the ones that the videos in the class refer to. So let's just talk a little bit about coordinates in 3D. We'll plot a couple things, and we'll see where we're at after that. All right. Now in 2D, this is what you guys have done up till now in your math classes. Every point is identified by a horizontal and vertical distance from the origin. All right. We call that an XY point. In 3D, we have ordered triples because now we have a z-axis. This is our conventional way of writing a 3D axis. So if we were in class together, if I was writing it on the board, I typically write the positive x-axis here, the positive y-axis here, the positive z-axis here. We typically don't write the negative axes because it just gets too cluttered because I'd have a line here, and a line here. And then if you try and plot on it, it gets kind of messy. So now what happens is we have a point in the XY plane, but it's projected above the XY plane along the z-axis. All right. So you can almost think of it as the top corner of a box. We've got the X direction, the Y direction, and then up is the Z direction. So that's what an ordered triple will look like. Now, what we want to do is start to think about what equations and functions will look like in here. Now, when we have a 2D plane, we have 4 quadrants, right? You remember the quadrants were kind of beat into you during trig, first, second, third, and fourth. Now we have 8 sections, so these are called octants. Mainly, we'll only refer to the first octant because after that, it gets a little bit confusing. The first octant is where they're all positive. If we're looking at another octant, it'll tell you like x is greater than 0, y is greater than 0, but z is less than 0. So that would be positive x, positive y, and a negative z. So it'd be down underneath the XY plane. So as far as referring, whenever you hear an octant, you'll really only hear, you're not going to hear second octant or seventh octant, so I don't want you to worry about that. It gets too messy. Now, we need to think about what these plots will look like. All right, and these are things that we can do with this 3D plotter. Normally, when you first go here, and you guys can feel free to follow along, or feel free to go and start playing. All right, this is a fun program. That's what this function looks like. But if I wanted to plot z equals 1, that's telling me every point is one unit above the xy plane. So I get a plane that is parallel to the xy plane, 1 unit above the xy plane. We could do y equals 1. The way you would do that, under select, we want to add a graph. We want it to be in terms of y equals this time. So that's down here. So y equals 1. It's still a plane, except now it's parallel to the xz plane. So anytime x, y, or z is equal to a constant, we won't bother with this one, we get a plane. And it will be parallel to the plane created by the other two axes. So even though we have 3 variables, they don't have to be in our functions. So anytime you want to go back to the beginning, you can just reset the app. All right, if you wanted to plot something like this, x squared plus y squared equals 1. Well, in 2D, x squared plus y squared equals 1 is a circle. And there's no z in here. When there's no z, it just means your circle extends in the z direction. So if we wanted to plot this, because it's not equal to z or y or x, this is where you would do what's called an implicit surface. Anytime you're plotting an equation versus a function, you do an implicit surface. So you can see it's already pretty close to what we got there. So x squared plus y squared equals 1. Turn it on. We get that cylinder, but if I look straight down the z-axis, there's my, kind of, right there. There's my circle of radius 1. I can't quite get it straight. It's a little hard to get them exactly where you want them. But what's happening is that circle of radius 1 is being extended in the z direction because z is actually not part of the equation. And that goes for any of these. You know, if we wanted to do, here's a cool one. Let's get rid of that. If you wanted to do z equals, oops, up here's where I'm at, z equals x squared. We know that x squared creates a parabola, but because there's no y, it just extends in the y direction. See how that vertex of the parabola just goes along the y-axis there? Now, here's something cool. If I add a y squared to it, I get what's called a paraboloid, because it's now a parabola in the x direction and the y direction and all the directions in between. Having that x squared plus y squared in there gives a circular look. The other thing I want to point out, remember when we had it x squared plus y squared equaled 1, so the implicit surface, that was our cylinder. You can kind of see it inside there. So you can kind of see the difference between when you plot a function and when you plot an implicit surface. Some of this is going to take a little bit of playing, which unfortunately we won't have too much time to do today. But I want to just get you started on this because we will use this program quite a bit. Okay, the distance formula. I want to bring this up real briefly. We're not going to spend a lot of time on it. It's just the Pythagorean theorem. Distance between 2 points is just the Pythagorean theorem. So that's our distance formula in 2D. That's nothing new. You guys learned that a long time ago in geometry. In 3D, it's actually really similar because basically you have a triangle in 2D plus this third side. So you just add the distance in the z direction. The reason I'm showing you this, if you square both sides, that gives you the basic formula for a sphere. All right, that's where the sphere comes from, because all the points of a sphere are equidistant from the origin. In other words, this d gets made to be a constant. You square both sides, you get your equation for a sphere. So let's turn off the cylinder. If I add in the z, there's our sphere of radius 1. All right. Oh, excuse me. Need a drink of water. All right. Let's take a look at a few surfaces so you can kind of see what they look like. Like we said, the sphere comes from the distance formula. It basically comes from squaring both sides. If you leave it as a radical, because we'd only get positive values, it would give you the top half of the sphere. So squaring both sides and doing it as an implicit surface, like we did here, gives you the full sphere. But if you did z equals square root of x squared plus y squared, you would get a half a sphere. We're going to see a lot of spheres in here as we go along. So there's the general form of a sphere centered at the point A, B, C with a radius of r. So it works real similarly to a circle in 2D. All right, so that's our general formula of a sphere. A cylindrical surface is a surface traced by a line moving parallel to a given line and intersecting a given curve. What does that mean? Well, that means we have a generating curve and it moves along a directrix. Perfect example was that parabola we were looking at earlier. So this guy here, not that guy, sorry, I want this one. The generating surface is this, the generating graph is the parabola, and then it moves along the y-axis, and all these lines along the y-axis, see those lines there? They're all parallel, all right? So this would be the generatrix. This axis, the y-axis, would be the directrix. All these parallel lines would be the rulings. Guys, do not worry about memorizing those terms. I do not use them in here. I probably won't use them in here again. But they are the terms for these things. What I want you to do is become more familiar with all these surfaces. Become familiar with seeing these surfaces. I don't expect you to memorize them, but just as you encounter them, you'll start to get more and more familiar with them. Again, and so when you see this as any equation missing one variable, like we saw earlier with the cylinder, x squared plus y squared equals 1. Right, so this would be our generatrix. Our directrix is the z-axis because it moves along the z-axis. So they're really obvious. They're always missing a variable. Here's another one. Okay. Quadratic surfaces get pretty interesting because in multivariable calc, we have 3 variables to deal with, x, y, and z. Do not be overwhelmed by this, guys. You're not going to see a whole bunch that look like this, but this is the general form of a quadratic in 3D. You know, if you remember back to algebra, ax squared plus bx plus c, we have to deal with interactive terms now in multivariable calculus, and that's why there's so many. We have 6 basic types. I'm not going to spend a lot of time on these guys because you saw them in the videos and you do have access to these notes, but there's just a couple of things I want to point out. So here's the 6 basic ones, and they all fall into certain categories because of something specific in the equation. So we're going to go through each of these in order, and you'll kind of see what the difference is. So an ellipsoid So traces, oh, sorry, let me not skip ahead. What we'd look at are traces. What traces are what it would look like in a 2D plane if you set the third variable to 0. So an XY trace is what the graph looks like in the XY plane, and the Z is 0. Here, you know, the XZ trace would be the parabola, okay? So that's what traces are, and what it does is it allows us to mentally simplify the curve, so we're only looking at a 2D image instead of 3D. And we'll do this with a couple of these. So the ellipsoid, number one, notice all positive. Ellipsoid kind of looks like an egg or a 3D elliptical shape. So all 3 degree 2 terms are positive, and the equation equals 1. And all 3 traces are ellipses. So if you spin this around, you notice you got an ellipse there, and you have an ellipse there. So all the traces are ellipses. A hyperboloid, notice the minus, creates, here's your hyperbola in this direction. Notice the trace in this direction would be an ellipse. So all 3 degree 2 terms present, 2 positive, 1 negative when it equals 1. One of the traces is an ellipse, the other 2, so here is a hyperbola, and then if we were to spin it, we see the hyperbola. It's kind of a cool looking shape, the hyperboloid. And the axis will always be parallel to the negative variable. Guys, I can't emphasize enough, please don't feel like you have to memorize all this stuff. I am never going to ask you what are the characteristics of a hyperboloid. All right. What I might do is ask you to match a function with a 3D graph. That's about as far as this would go. So what you want to be able to do is look at traces. So, you know, you zero out one equation. So if I zero out the z, I get x squared over a squared plus y squared over b squared equals 1. That's an ellipse. So I would expect to see an ellipse in the xy plane. That's what I want you guys to take away from this. Not that you have to memorize these characteristics. Hyperboloid of 2 sheets, you'll see they kind of have a break in here. Notice the ellipse in the xy plane. And then it's going to be a hyperbola in the other 2 planes. All 3 degree 2 terms present. Now we have 2 negative and 1 positive. So we have 1 trace that's an ellipse, and it's parallel to the 3rd plane instead of in it. And the other 2 traces are hyperbolas. The elliptical cone is kind of cool looking. Notice positive and a negative. So it's a cone, but it's a tip-to-tip cone. So big difference here now is the equation equals 0. That's why we're getting that little tip there at the origin. So 2 traces are hyperbolas. And we got another one that's going to be elliptical in the xy plane. Why in the xy plane? Because the x and the x squared and y squared terms are positive. An elliptical paraboloid. Look, notice only x squared and y squared are, only x and y are squared. Z is not. And now we just have it equal to z. So one of the traces is again an ellipse. And in this case, it's in the xy plane because those guys are positive. But the other traces are now parabolas because if I zero out the y squared term, z equals x squared is a parabola. If I zero out the x term, z equals y squared is a parabola. Sorry. And finally, hyperbolic paraboloid. Looks like a Pringle, you know, the Pringle chips, or a saddle that you might put on a horse. We'll see this guy again. Very similar to the elliptical paraboloid, except what happened, that sign went negative. Just like the difference between an ellipse and a hyperbola. All right. So we've got a hyperbola in this direction, and we've got a hyperbola in that direction. So it's actually the intersection of two parabolas. And this actually is the shape of a Pringle chip. For an honors project a couple of years ago, I had a student create a Pringle with a 3D printer, and she did it by making it a hyperbolic paraboloid that was cut out in an ellipse in the shape of a Pringle. And she used the 3D printer to print out basically a plastic Pringle chip. It was pretty cool. Again, I don't want you to feel like you have to memorize those, because you don't. I don't want you to memorize the characteristics. What I want you to get good at is taking an equation, looking at the traces, and being able to match an equation with a graph. All right, you'll get a little bit of practice of that in the homework. All right, one last thing I want to talk about, and then I want to make sure we got time for questions. So this is the worksheet for 11.2, and we're not going to get to it, but the question did come up, and it was a good question. You know, how are you supposed, you know, like I said, guys, I encourage you to submit this. I'm not going to require it because, you know, you guys have a lot of stuff to do. But if you would like to get participation points for 11.2, you can do each of these, and let me show you how you would do this. So let's say I wanted to plot a paraboloid. And so I do it here. And you know, you turn it in a way that, yeah, 3D printers are pretty cool. So that's a good one, Cooper. So what you can do is up here in the menu, you can print plot. No, that's not what I want to do. Sorry. Where? Oh, shoot. One of those days. All right, let's say we want to print this plot. You go to File and save it as a PNG. All right, that's an image file. Okay, so that saves it as a PNG. And then you're going to want to open up a word processor. So for me, I'll open up Microsoft Word. Sorry, I should have had this open. You could use Microsoft Word. If there's another processor you like, that's totally fine. I recommend Word just because it's what I'm familiar with. And what I can do now is I can bring over my plot, and I can type in here and say, this is number 1, plot of function. And then, you know, you can actually even use the math editor if you want to put in the math. I'm not going to put in the function because I don't want to use up our time for that. If it's an XY function, you know, x squared, this is the one we were going to do, x squared plus y squared. Where did my, oh, sorry. There we go. And so, and this is going to be, the reason I'm showing you this, 2 reasons. One, if you want to do this worksheet, this is how you would do it. Make sure you do all of them and just do them all in one page, you know, just keep going down. But I don't want you to submit Word documents. The reason is because we all may have different versions of Word. So before you submit, you're going to do File, Save As, and you're going to save it as a PDF. So this would be worksheets 11.2, and always, always, always at least include your last name in your file name, and also in the document. Because here's the thing, guys. If all you do is submit me the document, and I have 7 documents sitting in the same folder, I may not know whose is whose. So always put your name in the document and in the file name so I know whose is whose. All right. So if you would like to do this worksheet, I encourage you to. I think it's worth the practice. We just don't have, you know, it's 6:30 now, so we're out of time to do anything else today. But I highly encourage you to. It's fun to play around with this 3D plotter. Both. So questions on the exams. Guys, I told you we'll talk more about the exams when they get closer. Questions on the exams can be like homework questions, or they can be like worksheet questions. All right, so that's how you would submit any of this stuff. Now, also, as I mentioned before, for your, you won't have the 3D plotter for exams, but you won't need it. You will have the 3D plotter, obviously, for the take-home problems. So the problems on the exam, you won't need the take-home, you won't need the 3D plotter. No problem. Okay, and also, so for 11.1, I just want to reiterate that when you go to post in the forum, when you do your post, make sure to include the which section. So today was 11.1, and the problem number or problem numbers. And then if you're only submitting one submission for your group, make sure you have the rest of your group's name in there so I can give everybody credit for participating. If multiple people in your group want to submit, that's fine as well. I just want to make sure that I'm giving you guys the credit for participating today. Okay. Now, I want to pause there. You know, I know we're already past 6:30. If you got to get going, I completely understand. But I wanted to open up for any questions you guys might have about submitting for participation points. You know, the 3D plotter, I got to update the link and more because I know it's going to be the old link. So I'll do that right after class. And also, if you do worksheet 11.2, you know how to submit that. Good question. So the question is which forum to submit in. I will show you right now. So here is the course. If you go into forums, in-class solutions, all right? We'll make it real obvious. And the reason we're doing this, guys, is because we're only gonna have time for you to work on 1 or 2 problems. You saw today we're already out of time. I wish we had more to go through 11.2 a little bit more, but we don't. So the reason I'm doing the forums is if you want to see how somebody did number 3 because you worked on number 4, you can go to the forums. You also have access to the solutions to the worksheets in the course materials. So if you didn't finish your problem, because I know, you know, I really wanted to talk about 11.2, this is going to happen sometimes. If you did not get to finish your problem, go ahead and finish it after class. If you know you have access to the answer key, you have access to the solution, so finish up your own solution and make sure your solution is complete before you post it, okay? Other questions?
I'm just very confused. You said we're not doing 11.2 in class, but we're required to do it at home.
You are not required to do it. If you decide to do it, I'll give you participation points. Which, like,
is that like extra credit? I'm super confused. Oh, okay.
Participation points are extra credit because, you know, sometimes people may miss class, or, you know, there's sometimes people may not want to participate. So I don't force people to participate. So participation points are always extra credit. They'll go towards your homework. So if you don't have time to do 11.2 or you don't want to, I'm fine with that. But I do want to keep the option open for those of you guys who do. Did that help, Mark?
Yeah, I just wasn't. Yeah, that helps. Thanks.
Yeah, no problem. And guys, if you ever have questions outside of class about even a little stuff like that, especially in this early part of the semester, feel free to email me. One other thing I wanted to say, you know, before you guys go, real quick, you know, on the groups today, I did random groups. If you guys are fine with that, we can continue to do random groups. but I'll answer your question in just a second, Andre. But if you're finding that like there's people that you want to work with because you've worked with them in other classes, or you kind of formed a group outside of class, maybe through the Discord chat that Garrett had posted the other day, that's fine. What you can do is send me a private email and just say, me, Bob, Sally, and Jen would like to be in a group from now on. And what I'll do is we'll just start having the same groups, and I'm fine with that. Until we do that, I'll do random groups. The other thing I want to mention, and I'll send you an email about this. You guys can send me a private email. This is not public information. If any of you don't want to participate in groups, if you're a quiet person and you're not going to participate, email me and let me know. And let me know if you still want to be in a group, you just won't participate, or if you'd rather just work on your own, and I will respect that. I'm totally fine with that. I just want to make sure that, if I match that person up with somebody else, I don't want to have somebody with another person who doesn't want to participate, because then they've got nobody to work with, okay? So I'm going to try and accommodate, I want to accommodate you if you just want to work on more on your own. So email me and let me know if that's something that you want. Andre, when you post in forums, do you click on the forums and submit it? Yes. So if I click on the forum, you go to add new thread, and the subject would be the section and the problem number. And you can either put names in the subject or you can put them in the body. And then here you can upload images. So you'll just insert your images right from your computer. Did that answer your question, Andre? Okay, perfect. Guys, this first week, we're still getting used to this. Please, ask questions about this stuff. You can email me. Like I said, I answer questions over the weekend, no problem. Because to me, it's more important that we get off on the right foot, so that 2 weeks from now, everything is just smooth sailing as far as what's expected of you from posting and everything, and we can spend more time on the mathematics. Okay. Okay, guys, I apologize for going over, but I appreciate you guys sticking around. I'll hang out if you guys still have for a few more minutes. I'm gonna have to go here in a little bit, about 5 to 10. But I can stick around for another 5 to 10 if there are any questions that you guys have now. But for those of you guys who need to get going, go ahead. Have a great weekend. Don't forget to do the lessons for Tuesday. And I'll definitely see you guys next week. And like I said, guys, remember you have access to all the tutoring. Please take advantage of it, and I'll answer questions as well. Night, guys.
Hey, Mr. Clark.
Yeah. Hey, Richard.
I sent you an email, but I just wanted to explain. I signed in late. My wife had jaw surgery yesterday.
Ugh.
They were supposed to release her this morning, but they wanted to do some CT scan and get medication filled, so I just got home.
Okay. Okay. Yeah, no problem. What time did you get in to class, Richard?
Late. It was like 32 or something like that. So it was like you were talking about that the one assignment for the worksheet, the 11.2 was.
Oh, okay.
Points.
Okay. So yeah, absolutely. You can do that. And all the groups today did from 11.1, they did number 1 and one of the other problems. So if you want to get participation points for today, by all means, you can do number 1, and you can actually pick any of the other ones you want to do. And just, post those into the forum, and, I'm happy to give you participation points for those if you want.
Okay, definitely do.
Again, participation points are extra credit. If you got other things you want to focus on, like a wife with a broken jaw, for instance, and homework, don't stress over it, because all the worksheets have solutions and course materials. But I want to always give access to participation points, even if you're not able to be here.
Understood. Thank you.
Yeah, no problem.
Have a good one.
You too.